Welcome to this presentation on velocity-based training and using VBT in strength and conditioning. Before we get going with this presentation on VBT, I want to point out that almost all of the content in this presentation is the work of other people, such as Dr. Brian Mann, as well as other authors who we will cover. So the information on the slides will serve as a review of several pieces of literature rather than anything new or groundbreaking in and of itself. So why use VBT? Well, I believe there are three big reasons for using VBT in strength and conditioning. Firstly, we can use VBT as a form of autoregulation, and this is the biggest point and what we will spend most of our time covering in the presentation. And within this, there are three main ways in which I think we can use VBT as a method of autoregulation. Firstly, to account for all stresses and ultimately avoid overtraining and injury. Secondly, to avoid impeding an athlete that is progressing. And on the flip side, to avoid progressing an athlete that is not developing. We will also cover how we can use VBT to ensure we are training the desired outcome, which pertains more so to Olympic lifts and other power development exercises. And finally, we will cover how we can use VBT to encourage intent in training. Before we get into why and how we can use VBT, let's cover the idea of velocity profiling and creating individualized velocity profiles for athletes, because this is really the base from which we will work from when using VBT in the training setting. So what is velocity profiling? We can think of it as the velocity that an athlete moves a load at for various percentages of his or her 1RM. Velocities at corresponding percentages of a 1RM remain constant and consistent despite changes in strength. For example, if an athlete has a pre-test 1RM deadlift of 285 pounds and 80% of that is 225 pounds, and the velocity that they move that 225 pounds at may be 0.5 meters per second. Now let's consider a post-test situation where the athlete has a 1RM deadlift now of 315 pounds and 80% of that is 250 pounds. And here's the important part, the velocity that they move that 250 pounds with is still 0.5 meters a second. So although there was an increase in strength, the velocity at which they move 80% or any given percentage remains consistent. Knowing that velocity at a given percentage stays constant, regardless of changes in strength, we can construct a velocity profile for an individual athlete on an individual lift. So how do we find it? How do we go about constructing the velocity profile? When testing for a 1RM or other rep max at maybe a 3 rep max or a 5 rep max, you would record the velocities of each lift and note the percentage of each lift based off the eventual 1RM. Jovanovic and Flanagan suggested measuring concentric velocity over at least 4 to 6 increasing intensities of load, ranging from 30 to 85% of actual or estimated 1RM. Similarly, Sanchez, Medina, Perez, and Gonzalez-Badillo suggested performing 3 reps at lighter loads of slower than 1.0 meters per second, 2 reps at moderate loads of between 0.65 and 1.0 meters per second, and 1 rep at heavy loads of slower than 0.65 meters per second. Alternatively, going back to our athlete who has a final rep of 315 pounds, they may choose to take the following warm-up sets in their work towards that final rep of 315. So here we have the load, and next to it, the percentage, and next to that, the velocity of each lift. So VBT software will do some of the work for us, but realistically, it's important to find the best method that suits the environment you're working in and the athletes you are working with. It's important that athletes express maximal effort with every rep and use proper and consistent technique. We would then input the results of the test into Excel and create a scatter graph. Using the graph equation and the R formula, we can extrapolate the data to give us the expected velocity at any given percentage of 1RM. So in the table on the left, in the left column, we have the load of each lift. In the middle column, we have the percentage of 1RM. And in the right column, we have the velocity in meters per second. So we would use the percentage of 1RM and the velocity column to create the graph in the middle, and then use the Y formula and the R squared value to extrapolate the data to give us the expected velocity at any given percentage of 1 rm. So in the table on the right, starting at 10% and increasing in increments of 5%, we have the expected velocity. The strength of the relationship between load and velocity can be described by the correlation coefficient R, or coefficient of determination R squared, which in this case is 0.9954, which is strong. In the bigger picture, this just demonstrates that there is a strong linear relationship between load and velocity. So now we have a velocity profile for our athlete in the deadlift. We can use this to create an individualized version of the target velocity zones. So all I've done here is expand the table and added every percentage point from 1 to 100, and now have a velocity for every given percentage point. So now I can prescribe more accurate and more individualized target zones to target specific strength qualities such as speed strength or strength speed. Before explaining how VBT can play a role in autoregulation, we will draw on two papers where the authors propose VBT as an alternative to more traditional methods of programming, such as the percentage-based system, where we perform a 1 rm testing procedure and assign percentages for the following training phase based on the athlete's 1 rm. The first paper is titled "The Importance of Movement Velocity as a Measure to Control Resistance Training Intensity" by Gonzalez, Badillo, Marquez, and Sanchez Medina. When referencing the more traditional methods, the authors stated that none of these methods is entirely appropriate for precisely monitoring the real effort the athlete is performing in each training session. So why are these methods not appropriate? Well, the authors cited three main reasons. Firstly, injury risk when performing an RM test. Secondly, RM tests can be time-consuming when working with groups of athletes. And thirdly, the changeability of a true RM after only a few training sessions. In an earlier article by some of the same authors, they explained that movement velocity is a key factor in intensity. They said, the higher the velocity achieved against a given load, the greater the intensity, and this will influence the training effect. So going back to the original study, the authors suggested movement velocity as an alternative variable for measuring exercise intensity. Firstly, the first repetition's mean velocity, which is intrinsically related to loading intensity. And secondly, a maximum percent velocity loss to be allowed in each set. When this percent loss is exceeded, the set must be terminated. The second paper is titled "Researched Applications of Velocity-Based Strength Training" by Jovanovic and Flanagan. Here the authors also stated that the traditional percentage-based approach has multiple shortcomings relating to injury risk associated with direct assessment of 1 rm, changeability of the actual 1 rm after only a few training sessions, and finally, and most importantly, changes in day-to-day readiness caused by a normal biological variability, training-related fatigue or lifestyle factors like sleep, stress, and nutrition. And this here is really the concept of autoregulation. The authors estimated an athlete's daily 1 rm from submaximal loads using the minimum velocity threshold method. And this demonstrated the following trend. A more than 50 kilo difference between highest and lowest estimated 1 rm over the training phase. Highest estimated 1 rm was 30 kilos more than actual pre-test 1 rm. Lowest estimated 1 rm was 20 kilos less than actual pre-test 1 rm. So the authors stated that using regular, daily, or weekly estimated 1 rms may help coaches to adjust workouts if percentages of 1 rm are used to program training load. This approach would allow coaches to assess day-to-day variability in training readiness and adjust training plans accordingly. So what is autoregulation? We have two different definitions here. Firstly, one from Dr. Brian Mann from his book. Autoregulation is a volume management system used to regulate individual differences in work capacity and allows these differences to be self-governed and applied. And secondly, from a study by Mann, Thiefel, Ivy, and Sayers, autoregulation is a form of periodization that adjusts to the individual athlete's adaptations on a day-to-day or week-to-week basis. It's important to understand that athletes will have many stressors, and ultimately all stressors draw from the same pool. This will range from the stress that occurs from the actual training phase itself, as well as training activities outside of the gym, as well as other possible real-life stressors such as education, relationships, family, and social commitments and interests. A practical example of this is an athlete that has a late night the night before and is paying for it the next morning when he arrives at the gym. His central nervous system is in a fatigue state, and he looks at his sheet and he sees that he has barbell front squats and he has 3 sets of 5 reps at 80%. On a normal day, this would be manageable, but today it's going to be a struggle. So going back to our subpoints under using VBT for autoregulation, the first of which was to account for all stresses and ultimately avoid overtraining and injury. There are 2 big ways in which we can use VBT as a tool for autoregulation. Firstly, by making adjustments during a training session, and secondly, by allowing for adjustments to be made automatically by the athlete. So making adjustments during the training session. Many VBT devices will estimate your daily 1RM based off submaximal effort performed in warm-up sets. So we can assess daily readiness and make adjustments to the session. For example, an athlete with a pre-training program 1RM of 315 pounds, but a daily 1RM estimate of 285 pounds, well, now we can make adjustments to avoid injury and overtraining. And secondly, allowing for adjustment to be made automatically by the athlete. Using the velocity profile, we can just assign velocities instead of percentages. For example, instead of prescribing 80%, I would assign a velocity of 0.55 meters per second, because this is the velocity that pertains to that percentage. More practically, I could assign a velocity range of 0.5 to 0.6 meters a second. So now consider our athlete who's 80%, which would have been 250 pounds, but is now 230 pounds. 250 pounds for 3x5, which on the day would have been 88%, would have been a real struggle and could have led to overtraining and/or injury. So we've now accounted for all stresses and avoided a situation that could have led to injury. So now to our second and third point under VBT for autoregulation. We want to avoid impeding an athlete that is progressing. So athletes are capable of making significant gains in strength in just a few weeks. This is especially likely to happen when athletes have spent a period of time away from training or are new to this type of training. Tracking a daily 1RM estimate allows for changes to the athlete's true 1RM to be accounted for. For example, pre-training program 1RM of 225 pounds, but a consistent daily 1RM estimate of between, let's say, 250 and 275 pounds, well, now we know we can make adjustments to avoid holding this athlete back. Using a traditional percentage-based approach, these changes in strength would otherwise not be accounted for until the next testing day, which, as we know, may be weeks or months down the line. On the flip side, we want to avoid progressing an athlete that is not developing. Some athletes will make gains in strength in a much slower fashion, and so tracking a daily 1RM allows us to progress each athlete efficiently and effectively. Moving on to our second point, which was VBT to train the desired outcome. Using velocity, we can make sure we are in the correct velocity zone and therefore training the desired quality. For example, I want to train strength speed, so I know I need to be moving the bar or implement at between 0.75 and 1 meters per second. But this point pertains more so to Olympic lifts, such as the snatch, clean, and jerk, as well as other power development exercises. Olympic lifts are used to train explosive power. If I want to increase my athlete's vertical jump, I need to train the athletic qualities that go into performing a vertical jump. We know that improving general strength will go some way to doing this, but using Olympic lifts is a common way to train explosive power, which is a quality very much associated with many sporting actions. Explosive power and correct technique is often sacrificed for load. This is where we see bad technique such as less hip extension, more back extension, lateral foot movement in the catching phase, poor catches in general, and most importantly, a bar speed that is too slow. Instant feedback from a VBT device will tell us if we are moving the bar too slowly, and therefore need to decrease the load. A quote that nicely sums this up for us is one by Schmarzo and Van Dyke. Maximum intent plus most efficient form equals highest achievable jump height or bar speed. We want to make sure that we have a good loading phase, a good triple extension phase, and a good catching phase, as well as the appropriate bar speed throughout. A coach's eye is still needed to monitor technique. This concept is important for the bigger picture in that a VBT device, like any training tool, is exactly that. It is a tool to assist, but is not the be-all and end-all. In this case, a coach still needs to teach and correct proper technique. Moving on to our last point, VBT to encourage intent. Here's another quote by Schmarzo and Van Dyke that highlights the importance of intent in the training setting. If an athlete does not complete a movement with the highest possible velocity or with maximal intent, the power produced during the movement will be insufficient to create true performance improvements. VBT devices provide instant feedback to athletes and coaches, and this provides another external coaching cue which can increase focus and intent. A velocity metric is completely objective, and this can help athletes realize that they are not moving the bar fast enough. For some athletes, it's one thing to have the coach tell them they need to move the bar faster, but when you have a machine or a device in front of you telling you the same thing, it can really help to drive the point home. Coaches can take advantage of the competitive nature of athletes. Velocity provides an alternative metric for athletes to chase, and as long as good technique is always prioritized, this is possibly a safer alternative to athletes chasing increases in load. Finally, some considerations for velocity-based training. While VBT may be considered an alternative option in programming, it is not an alternative or replacement for strength training. VBT is not simply training at high velocity or training fast or training speed. Rather, it's a tool to measure velocity, whether that be a 0.15 meters per second maximum effort or a 1.5 meters per second Olympic lift. VBT is not a new concept. Coaches in the strength and conditioning industry have long been using the methods. Now the technology is just more available and more advanced. New or novice athletes may not be ready to train using VBT. Similarly, athletes returning from injury and athletes with compromised movement patterns or poor technique should not be put in a situation where they are encouraged to move the bar faster or chase a certain velocity. Technique should always be prioritized. Here on the references page are some of the sources I used to put the presentation together. Thanks for watching, and I hope you enjoyed it.